Hello, Coffee Scholars and Angel Pitch participants. My name is Dr. Scott Molitor, Professor of Bioengineering. I'm Senior Associate Dean for Academic Affairs in the College of Engineering, and I'm also Director of the Choose Ohio First for Engineering Entrepreneurship Scholarship Program, also known as the Coffee Scholarship. I would like to first congratulate all of you on your projects and presentations. You came up with some excellent ideas and successfully communicated both your ideas and the story of your own entrepreneurial and personal journey through our program. The judges were very impressed with each of your submissions. The Angel Pitch competition allows first-year engineering students to present their ideas for new products or product improvements to a panel of judges with entrepreneurial experience. The program is designed to get first-year engineering students engaged in the 3 C's: curiosity, connection, and creating value. These values are part of the Kern Family Foundation Engineering Entrepreneurship Network, or KEEN. The University of Toledo is one of 50 colleges of engineering that is part of KEEN. A primary goal of the College of Engineering and KEEN is to instill an entrepreneurial mindset in our students, allowing them to fully engage with the principles and applications of their classroom lessons, and to motivate them on focusing on becoming job market ready engineers. This training begins when they are freshmen and continues through their co-op and senior design experiences. The goal is to understand the bigger picture, to recognize opportunities, to acquire important professional and business-ready skills, and to learn from mistakes. These skills will add value to their engineering education and for their future employers. As part of this training, we invited all first-year engineering students to participate in this program. Your submissions were selected as the 6 finalists from these projects and were evaluated by our judges for the Angel Pitch. All finalists receive a cash prize that can be used for further development and/or prototyping of their project ideas.
Hello everyone, I'm Jacob Lombardi, and my team, who are known as the Problem Solvers, will be presenting our innovative solution, the Beverage Barricade. Along with my voice, you'll hear Cameron Poppy, Morgan Schuld, and Raya Short give you the rundown of our project that we're all really proud of.
So we came together as a team through the Coffee Scholarship Program. We had filled out an application for the Coffee Scholarship, which stands for Choose Ohio First for Engineering Entrepreneurship, because we all share the common goal to eventually graduate with both an engineering degree and training in entrepreneurship. So at the beginning of the semester, we were assigned to be a group together for this design project. And we were complete strangers at first, but we had one thing in common. We were engineers with an interest in business. So after our group was assigned to us, we made a group chat and started to brainstorm ideas for our design project.
In the beginning, we came up with several ideas for a product, but none of them seemed to fit us. We couldn't find an idea that we were passionate about until we thought of a spill catcher. We wanted to create a product that solved a common problem, such as spilling a drink. We were unsure of the type of material to use, and we debated using 3D printing, sponges, and coasters. To help envision the product, we drew the design concept on Inventor, which is the picture to the right. Next, we decided to use sponges and elastic to create a prototype. In the picture, pink is the sponge and blue is the elastic. Due to the flexibility of the material, the product is adjustable and is able to be attached to different sized objects. While designing the product, we wanted to target a large audience, which is why we came up with the Beverage Barricade. Currently, in the United States, 64% of the population drinks coffee daily, meaning 64% of the population could find the Beverage Barricade useful in their lives. We also found that the product could help those with medical conditions, such as Parkinson's or arthritis. People who are more prone to spilling a liquid would be able to use the product in many ways, such as on mugs, bowls, bottles, and anything else that pours and has the potential of spilling. To help envision the product, we drew the design concept on Inventor, which is the picture to the right. Next, we decided to use sponges and elastic to create a prototype. In the picture, pink is the sponge and blue is the elastic. Due to the flexibility of the material, the product is adjustable and is able to be attached to different sized objects. While designing the product, we wanted to target a large audience, which is why we came up with the Beverage Barricade. Currently, in the United States, 64% of the population drinks coffee daily, meaning 64% of the population could find the Beverage Barricade useful in their lives. We also found that the product could help those with medical conditions, such as Parkinson's or arthritis. People who are more prone to spilling a liquid would be able to use the product in many ways, such as on mugs, bowls, bottles, and anything else that pours and has the potential of spilling.
So throughout this project, we had a few minor roadblocks. For one thing, it took some time to break the ice and kind of get around the awkwardness of Zoom calls and meeting online. Good communication was also a small struggle at first for the very same reasons. Once we had gotten past all this, it was difficult coming up with a plan and idea that suited the requirements as well as our group. However, we realized that bigger is not always better. It seemed like we were constantly trying to come up with a new idea or a new plan rather than improving others' ideas, which is a difficult task on its own, let alone in the middle of a pandemic. As expected with many college students, time was very hard to manage in certain stages, but once we jumped right into this project, everything really just came together for all of us. And lastly, none of us had really ever tried to create a completely online presentation, so it was all very new to us. However, we took these setbacks in stride and worked together to conquer them.
Despite the roadblocks and obstacles we faced along the way, we ended up being very proud of our design for the Beverage Barricade, and we also learned many skills that will help us both in the professional world in the future and just in life in general. So the first and most significant thing we learned was we had to get more comfortable with communicating online, because COVID-19 and social distancing and everything kept us from meeting in person quite frequently, so we had to adjust to communicating through group chats and emails and in ways that we weren't familiar with before. And second, we had to learn flexibility because we all had different class schedules and majors. So we had to be flexible and work around everyone's schedule and finding when it was good to meet with everyone in the group and also different advisors. And we also had to be accountable and ensure that we worked on our design project bit by bit throughout the semester to meet the gradual deadlines, and we had to make sure that everybody was doing their part and holding everyone else accountable. And we also had to learn how to receive feedback and criticism from both each other and different advisors in the engineering department. And finally, we learned how to perform a market analysis and how to objectively weigh in on how our product compared to the competition in the market.
Okay, so this is our presentation for the Coffee Scholarship Program project, and we created a product called the Dry and Go. So, for curiosity and ideation, basically our brainstorming process, early on we decided to meet once a week to brainstorm possible product ideas to get the ball rolling, and then it came down to two final ideas, the Dry and Go, which we eventually ended up pursuing, which you'll learn about over the course of this presentation, and then we also came up with an idea for a waterproof Bluetooth speaker that could be used in the shower to listen to music. And we ended up pursuing the Dry and Go for several reasons. One, because it was really unique. From our research, we didn't see anything that was anything really similar to it. And then it also would have been more realistic to produce with our limited resources that we had available. And then also it fills a need rather than a want, which was an important thing. Basically, it'll do more good for the community as a whole.
For the connections and team building of this project, I feel our team developed bonds over our shared passion for the field of engineering, and especially with our interest in the business aspects of our field. And as we progressed on our projects and our journey, I felt we were more able to trust one another, to complete tasks, to just show up to a meeting. It didn't feel like there was any turmoil between our group.
When we were brainstorming ideas for a product, we were looking to solve an everyday kind of problem, one that many people could relate to. We then had the thought, what if we made a device that dried the insides of cups, specifically a device that could reach the bottoms and corners of cups that are hard to get to when hand drying with a towel? We then came up with a product that uses the properties of spring steel to force a towel against the sides and bottom corners of a cup or long container. The product was designed to be simple so that anyone could use it, durable so that it is dependable, and to require little force to operate, expanding the range of people who can use it. Simple is better as it allows for both an easier manufacturing process and lower prices.
So, for market analysis, we basically looked at the market and tried to find how big of a target audience we would have and who would use our product. So basically, our product would be really useful for all ages, actually, as like a convenience thing as well. However, it would greatly be beneficial to both the elderly community and those with like hand or wrist arthritis. These demographics usually have difficulty performing complicated actions with their hands, like drying cups or mugs. And so here's some statistics. Like 54 million people in the United States have arthritis, basically about a quarter of the population. And then there's also 48 million elders currently in the United States who would again greatly benefit from this product. And so because of this, our product should have a very large market to succeed in. So the market is large. So what need does the dry and go fulfill? So say you have a lot of dishes, but you only have a certain amount of space in your drainer. It's easy to dry like plates quickly with a towel, but with cups, it is a lot of times like more difficult to dry them. And so most of the time you just have to air dry them. And if you don't fully dry the cups, it would be unsanitary to put them back in your cabinet. So this would really just speed up the process and basically allow you to dry cups a lot faster than just air drying them. And then also say you drink coffee from the same mug every morning, and instead of just having to worry about washing it the night before every night and then letting it air dry, you could even wash it the same morning and dry it, so then it's ready to go for your morning coffee. So what meets this need already? So from our research, we found that there aren't really any products or patents on the market that allows the consumer to dry cups in a quick and simple fashion. It's just become mainstream, the way it's always has been, to just air dry cups, glasses, and mugs. But yeah, like previously stated, what if you're just trying to get the dishes done in a hurry and you don't really want to air dry them? So thus, the dry and go will fill a unique role in the market that has never been filled before. And not only do we have a large market, there's also no real competition for a product like the dry and go.
Our budget needs for this project were mainly the spring steel that we ordered and then the plastic that we used with 3D printing. But since we went through the makerspace, we didn't have to include that in our budget. If we made a final product, instead of going with our prototype, we would have used an aluminum tube and rod. And the pricing all added up to make it fairly cheap, but also with the tube and rod, we didn't. Those prices aren't in bulk. So if we ordered them in bulk, I probably could have gotten them down cheaper to where it been a lot more affordable. And then our problems and roadblocks for the project. Our biggest roadblock was ordering the parts, which was mainly my responsibility. I ordered our spring steel about 10 times too thin, so it was too flimsy and could not provide the support we needed. But even with that roadblock, we pushed through. We ordered the right thickness of metal about a day or two later. We got it in, we got it cut, and other than that roadblock, it's been pretty smooth sailing, and I think we've done pretty good.
For the lifelong learning and professional skill building, this project is very beneficial to learn and understand the process of inventing a product. We were also able to learn or refine softer skills like sending professional emails or reporting to the supervisor. The project was more serious and really pushed the group to act in a more professional manner.
And now Elijah will give us a demonstration on how the dry and go works. And that concludes our presentation on the dry and go. We hope you've all enjoyed and have a good day.
Hi guys, we are Toledo Paper, and my name is Tyler Welter and I'll be reading today. And our team consists of Russell Volk from Richfield. I'm from Maumee. Alex Peterson is from Toledo. Luke Risco is from Mentor, and Michael Messer is from Brunswick. And how did we come together as a team, you might ask? Well, as soon as we met up as a group, we knew immediately that we were motivated, hardworking, and wanted to do our best. We all put forth some ideas, and we immediately appreciated one idea in particular. We talked online and to make sure we had high morale and to make sure we were completing our tasks in time. When the time came for hard work, we were all on board. Problems to address, but which to solve. When this project started, COVID was in its first big wave, and we knew we wanted to help with it in some capacity. We also wanted something that our campus could use. With these things in mind, we decided to go with TOPS, T-O, toilet. P, paper. S, sensorize. A sensorized toilet paper dispenser. We have sensorized sinks, sensorized paper towel dispensers, and air dryers. So why not sensorized toilet paper? The design process. When designing our product, we started out with some rough drafts just to get our basic idea on paper and to try and visualize it. We then later upgraded those pictures into CAD files to 3D print out our pieces for our product. We then bought some electronic components and made a program and assembled our product to work. Problems and roadblocks. As with any big product, we encountered some issues. The thing we were trying to help was COVID, but it wasn't going down without a fight. It took out one of our members when we needed him the most, and another one later on. We had some parts that didn't fit initially, so we had to fix this, and we fixed it by sanding them down until perfection. Our springs were too short to begin with, so on a later model, we would buy bigger springs. We didn't research enough and ended up buying materials we didn't need, and we didn't have enough materials of the ones we did need. So, on a later model, we would also buy a stronger motor to make sure our toilet paper would roll enough. We all learned something from this experience. I learned that creating a life-improving product takes great cooperation, thought, and time. Russell learned that communication is key to a successful group. Luke learned that adaptation is imperative to overcoming challenges. Alex learned that preparation, research, and foresight are paramount to success. And finally, Michael learned how to have a short and effective meeting. I hope you enjoyed these slides, and thank you for listening to Toledo Paper.
Hi, this is Rachel Clemens, Nathan DeMuth, Benjamin Olmsted, and Sarah Pinchot, and our design project is an all-terrain dog wheelchair.
We came together as a team by first meeting just to get to know each other. Then we met a second time to brainstorm ideas, and we made sure to always listen and not discredit others' ideas. We came up with ideas by first asking friends and family for suggestions. When we met as a group, we talked through and weeded out some of the less plausible ideas. We got a little sidetracked talking about past engineering experiences that we had in our high school engineering classes. I had shared in my sophomore year that my group decided to make a dog wheelchair, but it really didn't turn out good. Someone looked it up and realized how expensive dog wheelchairs were to buy, so we decided that we could make one for a lot cheaper.
Our solution for this problem was to construct a PVC frame wheelchair. PVC was a good, low-cost, lightweight, relatively strong material, which made a good option for us. We also decided to add large all-terrain wheels that allowed the dog to go anywhere they would want. For different size dogs, we added the adjustability to raise and lower the wheels. Also, for easy use, we added the feature to strap in a harness to make putting the dog in much easier.
We designed and created our prototype first by thinking of materials that were going to be strong and easy to assemble. That is how we decided to do PVC because of how strong it is and also its low cost. Then we got dog measurements from Rachel's dog at home and sketched out a rough drawing on paper. After we were more sure about what we wanted to do, Benjamin made a SolidWorks model to go off of, and we bought supplies.
And then we ran into a couple problems during the build, and we decided to change it or fix it by one problem was buying materials, and where we bought the wrong supplies the first time. To fix this, we could have had a better plan of what to buy and paid more attention to what we had picked up. Another problem we ran into was drilling holes. It was difficult to drill the holes in a dorm room without proper tools. To fix this, we would build the wheelchairs in a proper shop. And the last one was securing the harness to the frame. Our low budget cloth was not the easiest to work with and did not supply the most secure attachment.
Personally, one thing I took away from this was that a good workshop and proper tools are really beneficial to build a high quality prototype.
And then I learned group communication. With my previous experience in group projects, it's always been with people I've known from high school because I had a small graduating class, knew everybody there. So here, going into a group project where I didn't even know the people who I was working with, I knew their names before I even knew who they were. So being able to work with new people that I've never met before, getting that experience is really helpful and beneficial.
I thought it was very interesting and cool to take the design of just an idea and make a prototype from it.
I learned how to be a better teammate and work better with others, and it was a really good experience to be working with people that were actually able, that I could trust to do the work.
Hello, this is Mechanical Engineering Team Blue. The second floor is the project that we came up with. It was designed by, as we dub ourselves, the Dinner Club. It consists of me, Triquan Eubanks, Nick, Adam, and Seth. Unfortunately, Nick is unable to record audio right now, so it is going to be just recorded by the rest of the team. He is having poor connectivity issues at home since leaving early.
As for team building, we really got together, and right off the bat we became buddies. It was just like an experience like no other. We all just kind of meshed together. It was really awesome. Our first meeting, we just got straight to business, you know. We had several ideas flowing around. Everything was just really awesome. Perfect team group overall.
As for coming up what we wanted to do for our project, we really wanted to do something that was not already initially a product. We wanted to do something different and that was out there that would really test our engineering skills. And after many ideas were thrown around, we came to the conclusion of two good ideas that could possibly work. And one of them was a sauce cup that would clip onto a ventilation in a car. But after finding out that it was already a product, we went with our second choice, which was the second floor idea.
The second floor takes advantage of the airspace in dorm rooms. Trey came up with the beginning of the idea when he was complaining about not having enough space in his dorm room for people to come over and hang out. So after that, we just took the idea and ran with it.
We wanted our design to be able to be in the dorm but not be permanently stuck to anything, because obviously most colleges do not allow inserts into the wall or, you know, things hanging from the ceiling. So we decided to hang it from the bed frame, and the base of the second floor consists of a PVC pipe with paracord interwoven at every 6-inch intervals, with chipboard laid on top and taped securely so that it creates a solid platform. We used carabiners to clip it to the bed and more paracord as the string so that it would hang in a loft style. This creates a flat surface above the near the beds, and then below on the ground where people can either sit or store more storage items that would typically be impeding you in your dorm room.
We ran into a few problems after designing the second floor. The first one being that the initial idea behind it was that we wanted it to be able to support a person that was staying overnight and there wasn't enough space elsewhere in the room. But after the design and prototype was finished, we found that it wasn't stable enough or secure enough to support a person. It could support a lot of weight, but with a person's uneven weight distribution and moving during the night, it probably wouldn't be able to support them throughout it. Also, the high density cardboard was not a cost effective material, and it provides a amount of flex that we really don't want in our product because we want it to be level all the way out. So changing material after some testing would be nice. Placement of drill holes could be better optimized for material efficiency and support. We really weren't able to test this throughout designing because it was once we drilled the hole in there, there was really nothing we could do to change it. And then the plastic carabiners were flexible, so when they were put on a corner, it would begin to flex around it and start to snap. So changing that to a metal carabiner would be nice. And then finally, being able to adjust the paracord to fit different sizes of beds and different distances across beds. That would also be beneficial, but that would require more testing and just more designing in the future.
This project has helped change our perspective on the engineering process in many ways. We learned that a good plan on paper isn't always the best for real-world applications. We learned this when we went through the testing and design process of our product, and we figured out that it wouldn't be as stable for a person to be on top. We plan to take these perspectives that we learned and apply them to the rest of our engineering career at the University of Toledo and beyond.
Hello, we are the Coffee Scholar Group in Bioengineering. Our names are Aphrodite Georgakopoulos, Zane Bates, Katie Knight, Lauren Mathis, Alexis Dusick, Evan Robke, and Corinne Rubel. Our product that we will be presenting is called Grabby Stick. Our team was constructed through Dr. Ian's freshman design innovation class as we were all placed into the Coffee Scholars group together. We then assigned a team leader, which is Aphrodite, and also assigned various mini-teams. These mini-teams are used when doing research and completing assignments for our group. We have learned that we are much more effective at completing tasks when we all work together, as we can all contribute our thoughts and weigh out one another's qualities. Working together has allowed us to completely organize and understand our given tasks. We are still working on our teamwork skills, but we have definitely improved compared to the start of the semester. Our team researched many ideas over a span of several weeks. Our ideas stemmed from issues that we face daily. The main issues that we were coming up with had to do with the current pandemic, but we found it quite difficult to incorporate bioengineering into sanitization. Our group realized that we wanted to focus on the elderly and disabled community, which is how we came up with our idea, Grabby Stick. By focusing on the elderly and disabled community, we have the opportunity to get real feedback and opinions from people that use item grabbers daily. We have decided to redesign the normal item grabber into something that can be easily used by our targeted community. Our solution is to design an item grabber that has a button instead of a trigger. This would reduce the environmental stress that is needed to work the item grabber. A force transducer is going to be used within our product in order for the item grabber to sense just how tightly the prong should envelop the item. This is going to work through a feedback loop within the force transducer. The 3 points of contact, or 3 prongs, are going to ensure that there is equal applied force around the item. Many item grabbers currently on the market have 2 points of contact rather than 3, but we believe that having 3 points of contact will be in best interest of our force transducer. We plan on using aluminum for the material of our prongs and shaft, as aluminum is durable yet also lightweight. The item grabber is going to be about 2 feet in length. Many item grabbers on the market range from 2 to 3 feet, but we believe that 2 feet is going to be best for even weight distribution of our item grabber. This is our current prototype model for our item grabber. The button to activate will be easy to push down, and directly above it will be a display. The display will show just how much pressure is being applied to the item. and the display will light up in order to show when the person needs to stop holding down the button. The reason for the light up is due to our target community, and the handle will have slight indentations to ensure that the person has a proper grip on the handle and it doesn't slip out of their hands. The team roadblocks that we encountered this semester are lacking proper organization. This was due to splitting up tasks. We faced trouble when we tried to divide work because we faced redundancy. We did not have enough meetings, which would have been beneficial in discussing our current research and avoid the redundancy issue. And we relied on our leader too much for management purposes. We have learned a lot from these mistakes, and we are still working to be our very best to not run into these issues again. Being in this group has taught us all a lot about how to avoid certain roadblocks and to become more efficient together as one group. We have learned that incremental innovation has been more valuable to the market. Clear and focused communication is necessary for success, especially when considering group work. Capitalizing on everyone's strengths makes an effective team, which is why we have decided to work on projects and research together as a group. We also learned that even small details are vital for the progression and completion of a project, and that everyone's part truly matters to our end goal. Lastly, we learned that dividing and conquering is very counterproductive to the type of project and research that we worked on as a group. Overall, our group has learned a lot over the past few months, and we are determined to progress even more as we work together throughout Freshman Design Innovation next semester. Thank you.
In third place, receiving a prize of $250, was Toledo Paper, with Michael Messer, Alexander Peterson, Luke Risco, Russell Volk, and Tyler Welter. In second place, receiving a prize of $500, was Dry and Go, with Luke Chesick, Neil Grimmick, Elijah Carl, and Dylan Pester. In first place, receiving a prize of $1,000, was Beverage Barricade, with Cameron Fopp, Jacob Lombardi, Morgan Schuld, and Raya Short. The remaining three groups will receive a prize of $150 each. Congratulations to everyone on their submissions. I would like to thank our judges, Steve Baum, an entrepreneur in residence at Mercy Innovation, Adam Solon, an entrepreneur in residence from Jumpstart, Joe Schultz, a healthcare expert and adjunct faculty in the Department of Bioengineering, and Fred Truhoff, a serial entrepreneur, financial and investment consultant, and startup expert. I would also like to thank Dr. Norm Rapino for his work with each group throughout the semester, and Dr. Soren Schock and Edda Yildur-Mayan for working with students in the bioengineering and MIME first-year design experience courses. I would also like to thank Jordan Valdez for his assistance with composing and posting the presentations. Finally, I would like to thank each and every one of you for your efforts in this competition. Best wishes for a successful completion of your fall 2020 semester, and I hope everyone has a safe and enjoyable semester break.